next up is Svenja. Is Svenja there already?
Yes.
Yeah, Svenja, now Scott is encouraging all these e-commerce companies to send out even more campaigns, and they're all ordering like I do, and then I send everything back because nothing fits. How we solve this? With SAIZ, right?
That's what we're trying to do, exactly. Perfect segment between the two.
That is so nice. Please, everyone, welcome Svenja Tegtmeier from SAIZ, CTO and founder of SAIZ. SAIZ is an AI-enabled software solution for apparel brands to improve fit and sizing from product creation to sales, thereby minimizing the number of product returns and maximizing user experience. Welcome, Svenja.
Hi, thanks for having me.
Svenja, congratulations, first of all. You just closed the funding round. Are you sober again and everything? I think it was yesterday, right? Or the day before?
Actually, it's always like a bit disappointing, right? Because it's actually a few months in between.
Okay.
Like now we just got to announce it, but yeah, it's still exciting.
Yeah. I saw it on LinkedIn yesterday and the days before. Congratulations for your business. That's a great achievement. Svenja, before we dive into your talk and what SAIZ is all about and how you think about the world of e-commerce, the one question that we all ask our speakers, what fascinates you about AI?
Everything. I think like I grew up with data. Big data has always been my thing, and AI just makes it so much faster to analyze. And I think that's really where it took off for me personally. Yeah, just seeing patterns in all the different aspects, connecting new data models that weren't available before, right? And learning out of them without you having to learn. Maybe it's like also an innate laziness actually, that somebody else can just take over the thinking for you, right? Which is very exciting. I don't think
it's all about.
That's what it's all about. Cool. Should I start? I don't think I can hear you anymore.
What's that?
Should I start or what?
Yes, the stage is yours. The audience is yours. I'm just the moderator. You're the show.
The moderator on the show. Well, welcome to the show. Let me get started, right? Today, fashion, an industry with unleveraged data. I don't know if you guys can tell what this is, but this is actually a bunch of fashion trash, right? So in the fashion industry, we actually have 90 million tons of fashion waste every year. That means roughly, to give you another number, a truckload every second that actually goes with fashion to a landfill, right? So, which indicates a huge amount of inefficiency that we have in this industry. And I'm going to tell you in a second how all of that connects to data and what we can do to solve this. But maybe for a second, thanks for the great intro already, Marcus. But I'm the founder and CTO of SAIZ, as mentioned, right? I'm currently calling from beautiful, very cold Berlin. In the right upper corner, you can see my co-founder as well. So we founded SAIZ in the late 2021. We're a fashion tech company, and we are helping big fashion brands to kind of improve returns and reduce overproduction, all that stuff. Which is great fun. But to quickly summarize, what is all of this about, right? Why am I talking about an industry with unleveraged data? Is fashion really an industry with unleveraged data? What is that statement all about? If you don't take anything else home tonight from my talk, besides these 3 points, I think this is key, right? Because analog industries, such as the fashion industry, actually have a huge potential for innovation, which first off is great for any new innovation, a lot of potential, right? Which leads to the second point. Actually, if you are in an industry with unleveraged data, such as fashion, such as manufacturing, et cetera, right? If you use that data clever, it's an easy way to differentiate yourself faster and effectively from your competition. And I think the third way, because it can be very daunting, and it's the big topic of AI and how do I use data and AI, right? And there's a lot of very, very eager startups around the world that probably are trying to solve something in your industry, right? There's us for the fashion people, there's different data science and machine learning students that want to get creative, right? So you really don't have to go alone. today I would love to present to you a little bit what we do, just as an example of what, for example, data that hasn't been used before in the fashion industry, how we use it to convert certain data points, bring them to the front of the supply chain, put other data back, and just connect data points that are already there in a new way. So hopefully this can serve as a little bit of an inspiration to one or the other, what data there might be in your industry, in your company, or just in fashion in general, and how AI can really be an awesome tool to dig up some inefficiencies and go about it. But maybe as a quick intro, right? And we've talked about it super briefly, return rates. Everyone probably knows, or if you don't know, in the fashion industry, ordering online, you maybe have noticed if you order different sizes, right? You try them on at home, you have to go to the post office, you have to send it back, right? Those are returns. There's especially the US, the UK, and Germany are huge return countries. So here we have an average of actually 50%, close to 50% of most of them, which is humongous, right? So we are sending back and forth a lot of clothes and boxes, which obviously add to that huge chunk of trash that we have in the front. And actually, we try to look deeper into what's the actual problem, right? Like, is really the end customer the problem? Our end customer is just not good enough at identifying what size they are, right? No, the answer is quite obvious to everyone, right? If you've tried fashion, you know that a size is not the same between brands, not even in the same brand, right? Like consistent fit and sizing is quite difficult to get right. And if you break it down into numbers, the fit rate, so actually like how well does my product fit into my customer group, is between 15 and 30%. So really, really low. Like if you take this as a satisfaction rate or anything like that, it's extremely low, right? You don't want only 15% of your product portfolio actually like fit your average customers. What we really see is that sizing and fit is kind of one of the key players. And I'm sure there's other industries where you also have like kind of this main thing going through the supply chain that's actually, it starts from the very beginning, right? It's part of the product setup, goes all the way to sales, right? And in the fashion industry, it really is fit and sizing. Getting it right from the beginning is hard. Selling it correctly in the end is really difficult. So it's one of those key elements where you just have a lot of inefficiency attached to it. So right now, how it usually goes, right? You make a product, so you make let's say a t-shirt, for example, right? And there's all this data surrounding that t-shirt, right? In order to get it produced, you have to send certain data to your producers, to your manufacturers, your design team, and collected certain data points. They put it on a fit model, and they made notes on that, et cetera, et cetera. But that data stays there. So that data that all somehow got communicated around the product development process never gets sent to any other department, right? And similar in sales. So when you have your sales funnel, right? You sell certain things to people, they come back, they don't come back, right? They come back for a reason, they don't come back for a reason. They actually get put on humans, right? So humans wear your products. But all that data also still doesn't get communicated back. So our dream is actually for the fashion industry to connect those data points, right? Bring the product information, the data that already exists, that the design team has spent hours and hours putting on papers and in Excel sheets and stuff like that, to bring that to the end customers in the online shop. And similarly, all the data that happens while shopping, right? While people are buying the clothes, while people are trying them on, all of that data, again, that gets sent back to the product people so they can actually design better, right? Make better choices for their particular customer group. So that's very vague, probably, right? Very high picture. So what does that actually look like, right? In order to keep it short, I'll just like give a quick intro to our product and then expand a little bit more on our tech and data, because that's the exciting part, at least to me. It's very exciting, right? So, but quick, what do we do? So we do a one-to-one matching. We actually have the data of one particular product and we match it to one user. So while a user is shopping online, for example, you're interested in these brunch pants, you can fill out a couple quick questions regarding gender, age, height, weight, and then you have a quick question about your body shape. You get asked about how many hours of sports you do per week. That helps us like adjust a little bit the weight distribution on the body, right? And with this, we actually calculate exactly your measure, or we get close to exactly your measurements, right? And have the exact measurements of that product. So you can play between the different sizes, really get an idea for how it fits on your product, on your body. And this happens for each product, right? So again, if you then shop a different product, if you go on a different page, you get a different size recommended if necessary, right? If there's a difference. So we really alleviate that difference of sizes between brands. Now the interesting part comes, right? So once we have that installed on the e-commerce stores, we start selling, so shops start selling with size, right? So we are able to now collect data in the sales channel. So we take this data from the sales channel and actually learn about what customers like, how garments are performing, what the fit rates between different groups are of products, right? And so here we really, the matching from the 1-to-1 becomes 1-to-1,000,000, right? So we can put your entire customer group or a brand's entire customer group through each garment at the click of a button, right? And really know exactly how this product, what is going well, what's not going well, what can we improve for the future if I want to design a product that's similar to this one, etc. What does this look like? Obviously, it's also not a magic trick, right? We can tell you, the data can tell you what's happening where, right? What does your customer group looks like? For example, here we have the product insights, right? So are your pants performing worse? Are your dresses? What category is going well? What category is not going well, right? So maybe for the next production cycle, we sit down with our brands and we really say like, hey, let's look at 5%, 10% of your product portfolio for the next launch. Let's try it out. Let's really sit down, select a category that we want to tackle. And let's decide, because you also can't jump 4 centimeters or something while you're changing a product type, right? Let's decide how we can slowly go about it. But this data for the first time actually gives fashion brands an insight into how their products are performing. Right now, product people or product teams in fashion brands have no way of knowing how their product fits, right? Unless they really try it on, and that's usually 1 or 2 people. So they really get a chance to try it on everyone. And we also obviously give the same in terms of like an average customer, right? Like really tell them like, hey, this is your perfect size medium avatar, your perfect size medium fit model, right? So they can really start using those base measurements. That's what it's called in the fashion industry, the base measurements, your base avatars. That is way, way closer to the actual customer group, and thereby obviously improve fit. And if you improve fit, you reduce returns by 10, 15, 20%, right? It makes a huge, 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 huge difference. So the inefficiency are really like, it's such an awesome and exciting way to reduce those inefficiencies, reduce returns, reduce overproduction, right? You don't order as much of the wrong size for the brand as well, right? You know more your customer group, right? You don't have to blindly order 25,000 XXL if you don't know exactly what it looks like. So if we go a bit deeper to the exciting stuff, the nitty-gritty, right? What makes it so efficient? Where is the machine learning in this? Where is the AI, right? What do we actually do? Why do we learn so smartly? So there's really, in order to get to what tech we use and what machine learning we use, I think first it's important to understand the base of the data. So what we collect, as mentioned, right, is product data. So we start with product data. I can also show you in a second what it looks like, but we start with the essential design elements that a brand uses, right? Like really, how is each size measured when it was designed, right? We have customer data, so we really collect customers and how they put and how their measurements are, right? How they cluster, etc. And we also have a huge group of data that's behavior data, right? So if we recommend you an M and we know your body fits perfectly in a size M, and you still choose the size large, right? Can we see tendencies that for certain products, there's a design preference, right? All these things, even more, we have also different nudges. So we can also analyze how different customer groups are responding to different nudges, but more on that also later if you guys want. But so this is really the golden triangle of our data. A quick, like on the product data, because that's usually what people are really curious about. As mentioned, we really use like each product's individual data source, right? So in the fashion industry, it's called graded measurement tables, right? So it's really like the design elements. We also are starting to work with patterns. So actually like the cutout patterns and other input factors, right? But we do that for each and every article, right? Each and every SKU, which to some now, obviously the first question we always get with every brand is like, that seems impossible, right? To process every article, like every product when it comes out, before it comes out, right? But we actually, so most brands or all brands work with PLM systems, right? Product lifecycle management systems, where you can have extensions. So we actually automatically always pull each new data. We are basically we're sucking almost like the data out at the source, and thereby it's actually really easy integration. It's a lot of data that we're processed for sure, but it's actually really easy integration with like one extension, and once that's built, we can always take whatever data we kind of need. And what's the vision, right? Like what's before, like we talk about the tech, right? I talked about the 3 big data inputs, right? That we need, or that we have, which means we translate that actually. And I think this is, I've never actually talked about this. I don't think even our investors know what this is, but we call it like I call it our fashion data warehouse, right? So it's really what's exciting about this, and I don't know, I hope there are some AI people in the crowd, connect me afterwards, because I'd love to hear what you think. But what we do is we translate each step of the data. So for example, right, the customer behavior, we actually have each step of the data raw, translated, and like future processed even, right? Because we do all these different analytics on it. We process raw, like at different stages of the analytics. It gets connected with different data points. And we actually have a humongous fashion data warehouse, right? Which is, I think, the dream for all machine learning people. That's also why we build it, right? Because you can run so many models on this. You can analyze so much that you would maybe never even think of yourself, right? That's what I mean, like the innate laziness maybe in AI, right? Because there might be some things, and we already discovered a few, that I wouldn't have thought about, right? There's connections between certain behavior paths and certain returns that come in, or like fit aspects, right? That we can see that we wouldn't, maybe by common sense or just thinking about it in our own human small brains, wouldn't have come up with. So that's really an exciting, for me personally, a very exciting aspect of also the future of our machine learning models and what we can do with our data, right? But to maybe get to the magic a little bit more, to everyone or to anyone that's interested, we can also go deeper afterwards in the QA. But what is the magic behind SAIZ, right? Like what we really to the core do is translate products and translate humans, right? And there's different, I didn't even like put all of this here, but there's different special models that you can use and combine in different ways, right? So for example, we do a lot of natural language processing. So back to ChatGPT, right? Because all this massive data, right, that we get from brands of all their products, we obviously can process ourselves, or by like a human can process in a reasonable amount of time, right? So we need to be able to read measurement tables that were produced in China, that were produced in Bangladesh, that were made in Germany, that were made in the US, right? Like all these different languages need to be processed. It needs to be processed whether or not it's a half bust that's in the measurement table, it's a full bust, you call bust chest, etc., right? So all these different things need to be on a spot. Self-trained computer needs to be able to read them, right? Which we did. So our NLPs, like we now process for humongous brands, right? We process, it's basically the computer power now that holds us up, and we process certain things in a couple hours, right? Because then overnight we let the pipelines run and stuff like that. But it's really cool that it's super accurate. Like I think we have above 97% accuracy also on our NLP. So it's really always reading the right things. And there's a few that get spit out every once in a while because mostly human errors where there was a space too much or whatever. But yeah, really exciting stuff. And then we also have, for example, what we take into consideration, right, for the product data is also fabrics, right? So how much cotton is in there? Can we take the material that we have in order to adjust the stretchiness, right? So our algorithms are obviously also always focus on how stretchy are different materials, how how do I need to make sure that, because our goal is always to know exactly what bodies fit into what product, right? So I really need to be super clear on how the product behaves in the shoulder versus the bust versus the hip, right? So I really need to understand the product to a T, which is very, very cool. And also we do so much interesting combinations, right, where we really have models that train on these massive data sets, find new patterns. We are now going into computer vision. So I think that's also, like, you can see it briefly here on the right. So we are also now going into an app. We have an app, or are soon launching an app where you can also measure yourself, right? Where again, we use insanely cool computer vision solutions and statistical adjustments. So again, like machine learning algorithms that adjust. And I'm pretty sure, I don't want to make false claims, but pretty sure we're going to have, from what it looks like right now, the most accurate one on the market. We worked really, really hard with also partners overseas to get that measurement really accurate. And everyone that's in computer vision knows that only pure computer vision, it's really, really difficult to measure humans or measure objects over cameras, right? So we build actually a statistical model that adjusts for different lenses, that adjusts for different bodies, all that cool stuff. So yeah, I think really cool kind of things, right? To summarize, I think that's what the industry was lagging, or I mean, what you can do in an industry that does have all this data is superb, right? It's very, very exciting because nobody has looked at this data, and this can be a game changer. Like, we've seen what it can do for fashion brands, right? You can have return rate reductions immediately from our size recommender, but you can also have return rate reductions really when you improve products, right? And obviously, even though it's cool AI and the biggest data set and blah, 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 it's obviously not a magic bullet. It doesn't happen overnight. These are processes we need to work for months and years with our brands to over time get them where they need to be, right? But it really shows, I think, an awesome use case on how you can look at an industry that has data that doesn't have a ton of AI solutions, right? Where for sure the most of the brands don't have their own AI teams, unless you're maybe Nike, right? Most fashion brands don't have AI teams or look at their data in that sense. And if they look at data, it's mostly marketing data. So it's really, really interesting, I think, what you can dig up in analog industries. And I'm sure there's lots of other industries that have really cool production data that doesn't get used right now, or other sources of data, right, that would actually really move the needle in terms of inefficiency. So again, I think it's hopefully some degree of inspiration on how even analog industries, where you think there's not a lot of cool AI solutions, where the buzz is not quite there yet, right? That there might actually be the biggest potential, right? And that it could be a huge differentiator if you are an early adopter, if you work, again, this goes to the third point, right? If you don't go alone, right? If you adopt or work with startups, work with motivated data people, machine learning people, to really see and dig up some inefficiencies, because something always comes up when you combine full data sets. So I think that brings me to the end, 9:15. So hopefully I made up for a few minutes, but I think we have a short Q&A. But yeah, happy to connect. Let me know if anyone has any questions. That's my email or website. Find me on LinkedIn. But yeah, thank you.
Svenja, thanks so much. You are finally solving my biggest problem in e-commerce. I can tell you. Yesterday I was actually in a store, in a physical store. I had to run through 4 stores to actually find my size. And online, I find 1,000 things, but nothing fits, and I always send it back. Now I actually can act sustainably. But we actually do have a question from the crowd, from Vivek. And first of all, he or she says, thanks for an amazing talk. I have a question. How does the app work to take human body measurements? Is it accurate? And what tech is used to achieve this?
Yeah, so it's really accurate. We're still piloting, right? So it's not out right now with any brand or anything. So we're looking for the right first partner actually to launch it with. But right now it's an iOS app. We don't have an Android app yet. And again, it's not out yet. It will take us a couple more weeks or months to really publish it. But it basically, so in order to not give away everything that's behind the patent, but we take pictures, right? We take 2 pictures, because I think everyone that computer vision, you mostly need 2 pictures, it's so hard to estimate, like for example the stomach, if you don't take 2. So there's 1 front picture, 1 side picture. The app actually has a little video. It guides you through like how you put the phone, for example, in a certain angle against the wall. Then it takes a picture of you from the side, and you put in a couple more inputs. So you put in, for example, how tall you are, how much you weigh and stuff, so for references. And we take pictures. We have first measurements actually from the picture, and then we adjust them through our statistical models. So that's like, I think, the short answer on how we are nudging there the impact or the results of our computer vision.
Cool. Edward.
Yeah, because Svenja, we have another question from somebody called AS. The question is, what kind of AI engine is your solution based on? And is it an open source engine or is it proprietary?
It's proprietary. We don't really use open, I mean, we have a couple libraries, obviously, that we use to for training data, especially on the computer vision. We obviously didn't create everything from scratch. So a lot of there's a few common open source libraries, but most is actually proprietary, especially everything around our product, like our product algorithm, because it just doesn't exist. To my knowledge, there's no other AI that reads product data and translates into 3D products, what they really look like and how stretchy they are and stuff like that. So that is completely proprietary. And it's different combination of models, right? Like it's also, like as mentioned, right, one of the key aspects is actually NLP. In order to even get to a usable raw data, to a manageable, because we have masses and masses of data. Just to give an example, right, there are certain brands that have 70,000 plus products, right, and launch I don't know, a couple hundred every week and stuff like that, right? So even for those, it has to work. So these masses of data we read really quickly through NLPs, and then the adjustments are, there's some rule-based that's actually, there's always like different rule-based, then it goes different machine learning algorithms back into rule-based. So there's a lot of different steps, and I think over 20 models maybe in total. So it's a lot.
Cool. Svenja, thank you so much. Fashion retailers out there. I was also thinking about Scott's small and medium business owners who can then actually afford returns and everything, right? They compete with the big ones because the cost of returns is really, really low, right? Yeah. Svenja, thank you so much for tuning in so late. It's 9 here. It's a little bit past 9 here in Amsterdam and in Berlin. Thanks a lot. Contact Svenja on LinkedIn. It's worthwhile. Thank you so much, Svenja.
Thank you. Have a great evening. Bye.
Thank you.
Thank you.